So the resistance of the coil should be around 3 ohms. Radius about 4.15. So after finding an AC to DC voltage conversion formula online, this is about approximately what I got for amperage. And so I did the calculation here, a standard calculation for Earth, and I got about 115 microteslas. So now let's do this for DC and see if we can get again, this is a single measurement, but let's do DC and see if we can get a more accurate measurement. So let's just turn up the amperage and see how far we can get. If we can get at least to 45, so that's 45. Okay. So that's 45, at about 0.136. So here's the calculation. B would be B at the center coil, or B sub coil times tangent equals B earth. And then you would just solve for B earth. Here, the calculation gave about 32.8 microteslas. If you really want to be more precise, you would make a graph of all the angles. And this would be all the angles. And this would be the current or amperage here. And then this would be something about like this. So you would get something maybe like this or like this. I'm not sure. And then you would just have a line of best fit. And this line, the slope of this line right here, should be your B earth field. So, or that should be your earth field. I'm pretty sure this is how it works. I also don't have something like a resistance in series. A resistor, like either a resistor or a rheostat or something, whatever kind of device that has resistance in series, that would help be a little more precise for the control of the amperage. But otherwise, for a single measurement for DC, this is good, and you can clearly see that DC is much more superior to AC. AC has a big problem where it is not really stable. AC goes back and forth. Also, you have to do that AC to DC conversion, which I did do, and so yeah, there you go.